Hey, thanks for watching. Today's video is going to be working through all these guys, also known as multi-step equations with fractions and decimals, okay? I know I only have one here with a decimal, but hopefully you'll kind of see how to work through those as well, just given one example. I wanted to spend more time on the fractions. Hopefully you watched my other videos on multiplying fractions, dividing fractions, reducing fractions, solving equations with fractions. This should probably be like the next step after that. So if you see any of this stuff and you're like, dude, I don't even know what you're doing, maybe go back and watch some of the other videos that I've done. Okay, let me rewrite this over here. And again, I wrote, for this lesson, I'm putting them all up here just so that you can practice on your own and get started. If you think you know what to do, then solve them all, right? It's much better for you to solve these things on your own, get them wrong, go, oh dang, and then watch my video and then see where you're making your mistake. You're gonna learn a lot from doing that. So the pattern is gonna be very, 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 very similar every single time, all right? You're gonna wanna isolate the variable and then work through it from there. So what I mean by that is we're gonna have to get rid of this on both sides. Okay, so we'll need to subtract 2 from both sides. And if you're saying, oh man, I forgot how to do this part, that's okay. Let's just work through it together. 1 equals, let me use some space over here. So 3/4 minus 2. Now different books and teachers are going to teach this different ways. You need something equivalent to 2 with the same denominator. What I usually like to do is just say, well, I'm going to multiply these 2 together, which is going to give me an 8, and then the 4 is going to be the denominator that I'm going to use again. It's a pretty quick way of getting your common fraction or equivalent fraction to the number by using the denominator of the other fraction. Gosh, that sounded kind of complicated, but really what you're doing is you're just multiplying the number, the whole number you were given, by the fraction or the denominator to get the numerator, and then you just reuse that guy. So 3/4 minus 8/4 is what? Negative 5/4, right? Okay. And so now we're pretty much looking like how we were doing those other problems, or what needs to get done. We multiply by the reciprocal because it's a fraction. What you do to one side, you got to do to the other. Okay, and like I said, some books, we know that's all going to cancel out. Some books are going to say, oh, hey, wait a second, you have a 4 and a 4, so you can reduce that, or you could just multiply straight across and come up with an answer that way. So when I say reduce, well, you could cancel out the 4/4 because 4/4 is just one whole, and you could cancel that guy and that guy. I draw in the ones just for demonstrative purposes. Okay, if you were doing this on your own, you might not want to do that or need to do it. I'm always going to kind of go every single step so that you really see what I'm doing. And then as you get better at it, feel free to kind of take shortcuts on some of these. But if these both become ones, then there really isn't much to do. Negative 5 times 1 is negative 5. 1 times 1 is 1. Can I adjust that or change it or simplify it? Yeah, I could just say negative 5, okay? And so from there, I have my answer. Yes, I could plug it in right here and do 1/4 times negative 5, add 2 to it, and I should end up with 3/4. Let's move on to the next guy here. I want to kind of move at a good pace. I don't want to go too fast, but I want to move at a reasonable pace just so that you kind of get used to working through these kind of things. Fast, efficient, however you want to say it. Let's see here. 8 minus x over 10 equals 3/5. All right. Let's move this guy over first, right? We got to get the variable thing all by itself. So we're going to subtract 8 from this side. What you do to one side, you do to the other. Okay, so we know that guy is a 0, and we have negative x over 10 equals, oh dang, I got another problem over here. So let's do 3/5 minus 8 okay, is the same thing as 8 times 5 is 40, and then we have a 5 over here, okay? So remember, we use that little trick. We just multiply the top number by the denominator to get our equivalent value. So we have 3/5 minus 40/5 is negative, oops, let me erase that, 37/5. All right, that looks pretty. Okay, but you know, problems are gonna look like that. And so that's okay, we just roll with it. We have a negative x over 10. We could look at that as negative 1x over 10, right? Because that's gonna give us a fraction to work with. I guess we could even circle that guy too, because that's part of it. So now that we have a negative 1/10, we can multiply this side by negative 10 over 1. What you do to one side, you do to the other. Our x is now isolated. We multiply straight across. Now, when the numbers start getting big, maybe it's easier for you to reduce it along the way. You have a 5 and a 10, which you can reduce. Why don't I do it both ways? If we do negative 37 times negative 10, you're going to end up with negative times negative is positive, right? So we're going to end up with 370 over 5. Or we could reduce this and this. So if we reduce that guy and that guy, we could make it into a 1 and a 2 and see what we get. The negative stays there because we still have a value right here going on, okay? If this was negative, then the negatives would cancel, but I have a negative and a negative divided by a positive is still negative. So we have negative 37 times negative 2. I don't know what that is, but that's why they invented these things, right? If you need to do it the long way, that's fine. If you need to use a calculator, you can. The answer is 74 over 1, or, now I'm kind of losing my space, we could just write it as 74 and put some nice boxes around it, okay? Some people like the giganto fractions here and then use your F to D on your calculator, especially if you're using like the TX30, 32 or one of those. You can just reduce the fraction in your calculator doing F to D. Or you could rewrite it like this and then kind of simplify after you have the number. Some people like to reduce it along the way. It's a good practice because later on in like Algebra 1 and stuff, you're gonna have x squareds on top and bottom and all kinds of other values that you can reduce. It's just a matter of what you prefer to do. You could have some big answer and then cancel everything at the end, or you can reduce along the way and then have less to work with as you kind of wrap up your equation. I don't think either way is better than the other. I've seen students use both methods and be completely successful. So I don't want to preach one way or the other. Find what works best for you because you know you're the one in the class. You're the one that's going to need to solve this stuff. All right, let's do the next one. Let's see here. 2/3 a minus 3 equals 1/3. So when it comes to doing these, you know, a while back I have a lesson on the distributive property where you draw your rainbows and you distribute this value, okay? It works every single time, but now you have 2/3 a minus 6/3 equals 1/3, and now you have even more fractions than when you started this problem. It's gonna work, but you could do a little shortcut with problems like this. We need to get rid of the stuff next to the variable. So whether it's a 1/4 times c or an a minus 3, this is the guy with the variable. This quantity here is the guy with the variable. This is the thing we need to kind of get by itself. So we can multiply this side by the reciprocal of the number that's next to it. And what we do to one side, exactly 3/2. We do to the other. So this guy all cancels. This is just a minus 3. If you want, when you drop it down to the next level, you can take away the parentheses because there's nothing next to it, okay? If this guy was here, you need the parentheses to show, hey, just make sure that it's something -3 gets multiplied by whatever is out here. Once everything out here is gone, you don't need the parentheses anymore, okay? We can multiply straight across, or we can just reduce along the way. For this guy, I think I'll reduce along the way, and I'll make those into 1s. So we end up with 1/2, all right? From here, you should be a little bit better now at isolating the variable even further. We have a -3 equals 1/2. So this is our barrier. We do the opposite of -3 and we +3, right? Or I guess technically you add 3. Call it what you want, okay? Whatever is gonna help you get this stuff right. That's why I'm doing these in the first place. 1/2 plus 3 is 3.5. And you're all set. So you can use this little trick here to get rid of stuff. Yes, you could distribute. My only concern is that as you're learning this, it's a lot. Now you're creating more fractions in a problem that already has fractions. And how many fractions do you want to deal with? And what if this one over here was like 7/9 or 7/11, I guess you could say. Because now you have even more stuff. Now you got to like convert fractions and simplify and do even more stuff. It's just in your best interest, if you can, to crank through these by knocking things out efficiently. Okay, so again, if you've been pausing the video and trying these on your own, I hope you're being successful with it. If you're not, send me comments. Let me know where you're still struggling on these guys. I wanted to do one with decimals because decimals are pretty much the same thing every single time. Really can't go away from this too far, except just like make them negatives and stuff. Oops, let me erase that. Well, that's bad. Okay, that's not too bad. 10.7. Okay, let's see here. I gotta isolate the variable, right? Just like it's this time it's this. So this is my barrier, minus 4.3, minus 4.3. So 2x, negative 2x is left all alone. And on this side, I have 10.7 minus 4.3. Get a calculator, do it on your own. I don't know how you're being taught this stuff. If you have a calculator available, then just subtract and get 6.4. And if you don't, then do it the long way. Subtract 4.3 from 10.7. Okay? And then from here, we need to further get this guy by itself. Remember, that's negative 2 times x. So if it's a times x, we do the opposite and divide. Divide by negative 2. And what you do to one side, you gotta do to the other. Gosh, I'm saying these rules over and over and over, and I'm really hoping that you're catching on that a lot of these basic rules will push you right through a lot of these types of equations. And so practice them, say them, come up with your own saying, okay? Whatever's gonna help you remember how to get through these guys, that's on you, okay? Let's cancel all that stuff. We read our fraction down. 6.4 divided by negative 2 is, well, this one we can just do, I can go kind of quick because I'm just cutting both of these in half. So what's half of 6? 3. What's half of 4? 2, okay? And if you want, check it in your calculator, all right? Because I will right now. 6.4 divided by negative 2 is negative 3.2. Okay, so I wanted to do a decimal problem as well, but I wanted to show you that it's pretty much the same thing as the other ones. It's just a matter of isolating the variable and then coming up with that final answer. So thanks for watching. Subscribe to my channel, send me messages, check out my other videos, and I'll be seeing you.